So Python is like you use it as an interpreted language. So I'll just give a brief intro about how Python works. So uh, like this is called Jupyter Notebook. Okay. So Jupyter Notebook is it's like a cloud resource provided by Google, wherein they allocate some of their resources to you. So you can basically run this cell using Shift Enter. So here you can see that it is first connecting, right? It will like connect to some like RAM over cloud, and then it will run. So this entire thing, it is called a collab notebook or a Jupyter notebook. So here you can do two things. You can either do code or either you can do text. So I've made this thing using text. This is called a markdown language, not language, but some format of writing. So this exclamation, this exclamation mark, what is it? This hash is used
Hash.
basically as heading number one, and the double hash. Yeah, this is what happens when you do things for too long without just you just code all day without talking. So this double hash means heading number two, and so on. So this is like your normal text editor. So I can write my name is Batsy, and it will just display it like this. So and you can just add or delete cells like this. So each of these cells run some code. So let's have just run print AI cannot take over yet. So all I need to do is run use shift and enter, and it will run the cell. So just raise your hand if you have if you are able to run this. And by the way, do not make changes into the collab notebook. What you can do is go to this file and use save a copy in drive. So what it will do is it will create a copy, and from there you can run it. Has everyone made the copies? Like take couple of minutes to do so. So uh, till then I'll just tell you like why we use Python. So Python, it's a dynamically typed language, and it has too many libraries, like more than you can memorize. And these libraries, they come in very handy when you are doing something like programming. So essentially, Python is like a language that wraps up together. And you can do functional programming, you can do object-oriented programming, and you can also make executables out of it. So basically, it's so general purpose, and you can use it for virtually anything. Like it's even used in like embedded devices on such as Raspberry Pi and Jetson Nano. So a Jupyter cell is just having a Python backend, and like yeah. So let's move on, I guess. Okay, so we'll start off by declaring a variable. So declaring a variable in Python is very simple. Unlike C, you do not need to declare the type of the variable. It will auto infer. So as you can see over here, x equals to 10. We know that logically it makes sense for 10 to be an integer. So this x will be, you can just write in type of x and type of name, and you will see that it is able to infer it automatically. See, it's this type function tells you whether the variable is of integer, string, or some other data type. So had I just put some strings over here, it would become a string data type. See, while printing, it will obviously look the same to us, but still. So is that any question in the chat box? Can you repeat the commands? Yeah,
Like I
shift
have taken
center.
care of that.
Okay, thank you, Bhavik.
Chat box I'm taking care.
So should I
You
move forward?
inform me.
Yeah. Okay. Thank you, Bhavik. So I'll just discuss some basic data types in Python. There are a lot many data types, but we'll start off with the basic ones, the ones that you have done in C. So we have integer, we have float, we have string, we have boolean, and we have none. So integer is like well, this is again a markdown cell. So integer is like it's the data type wherein you can have arithmetic operations. So numbers are supposed to be integers. Floating point are like integers. They have just they almost have the same operations as integers. Just a couple extra, and then we have strings. So you must have dealt with strings in C. We didn't have char. We just that in both and the entire word alice will be of the same data type string. And then we have bool, or I like to call it boolean. Well, this either a true or false value. So we'll be discussing about this in a while. And then there is none type. So does anyone know what null values? Like, just give me a reaction on that if you know about null values. Okay, then I'll just tell. Null value is like well, when we in C you must have done this allocating memory locations to a variable, and it intrinsically holds a value. None type doesn't have any value as such, but the thing with none value is that if you use it in any operation, then the output of that operation will be none. It can be instantiate. It can use or it can also help you to debug stuff. We'll be encountering this later on, but for now, let's discuss arithmetic operations. So, arithmetic operations are like addition, subtraction, multiplication, division, modulus, exponent. So, in Python, we will be having we'll logically apply them on either an integer or decimal. You can't actually get any of that those operations on string, right? So that is why, I'll just give you an example. So let's just run this cell. And the outputs are supposed to be like very trivial values. See, it's the so just you just need to remember the syntax. That's all. So plus, minus, multiplication, and division are all very they're very simple. Modulus, it is a percentage sign, and for exponent, it is a double star. Then we have plus. So where you compare two values. So we have equals, not equals, greater than, less than, greater than to, or less than equals to. So by the way, the this after a hash in Python is called a comment. So a comment is something that do not execute in a code, but is used to add readability to it. So syntax for equals to is equals to, for not equals to is simply an exclamation mark and equals to, and for other greater than equals to and less than equals to mnemonic, in the sense that the comparison operator then equals to it. So it will be memorized. So yeah, just you can just run itself now. Then we'll move on to this assignment operators. So assignment operators are like let's say you want to add x equals to x plus 5. Just you write and as x plus equals to 5. So similarly, we'll have minus to some value, multiply equals to some value, to some value, remainder to some value, and exponent equals to some value. So that is just the basic way of doing it. So then we have logical operators. So logical operator is like, well, when you do logical operators are like and, or, and not. So by default, they are supposed to be applied on Boolean values or bool values. So the catch here is that x plus x greater than equals to 0, where x is 5, it is supposed to give you a true result. So these expressions, x greater than equals to 0 or y less than equals to 20, they will all yield true and false, and be yielding a true value if both of them will be true. Otherwise, it will give a false, or will yield a true value if either of these two comparison operators will give a true value, and not will just simply invert it. So x greater than 0 is well true. So not result will be, it should be false, right? Similarly, we have bitwise operators. So a bitwise operator applies the operations on binary numbers. So we just simply convert these values to binary. Okay. So 5 is converted to 0101 and 3 is converted to 0011. So we just take the maximum number of bits here for applying the operation. So um, so a bitwise and bitwise or bitwise XOR, we have not, left shift and right shift. So what AND does is takes the bitwise AND of these values. So 0 ANDed with 0, which is 0. 1 ANDed with 0, it is again 0. 0 and 1, that is again 0. And 1 and 1 is again 1. So the output should be 0 0 0 1. So I'm just gonna run this, and so 5 and 3, where's the and symbol? And 3. It should give something like 0 0 1, which is 1. So let's see the output. It's 1. And when you do OR, it's expected to be 1 here and here. So this is 6. This is 6 plus 2 plus 1. Sorry, 4 plus 2 plus 1. That is 7. 6 percent. Oh, XOR. Sorry. Supposed to be OR here. Typo. Yeah. So this is for XOR. This is for like negation. So if we invert the bits of 5, it's giving us -6. So why is it -6? Well, it is using this different sort of format. So the so this will be this will be the negation of 5, which is 6. But and since the first bit is 1, that is why it's a negative sign. So that is standard architecture rules. I just encourage you all to like read about big Indian notation, small Indian notation, and then about this signed integers, unsigned integers. So that way it will be more clearer to you. And then we have this uh, left shift and right shift. So 5, if we add another 0 to the end of it, it is like multiplying 2 to it. So it should give us 10. And if you just do the opposite, it should be like dividing it by 2 and taking the ceiling function of whatever is the output. So it should be 2. Yeah, sorry, floor. Sorry, my bad. So yeah, we take the floor of that, and basically now we move on to lists. So lists are like these are container data types. So I'm just gonna correct this. Uh, yeah. So a list is a container data type. So you must know about arrays. So list is like the array that we have in Python. So it can contain elements of different data types. So as you can see that the example list here has a integer value, some integer values, and some string values. So unlike like C, you can have different data types in a single array. So this is called a list, and you index them simply by this index is called the zeroth index. This is called the first index, second index, and third one, fourth one, and fifth one, and so on. So, unlike an array, a list is of infinite length. Like you can add as many elements as you want to it, and it will just work out. How it is done in memory? Well, it's a dynamic allocation. So, I'll just encourage you guys to check that out. Uh, the memory allocation for list, how it is done. But for now, we'll focus on the operations that we can apply on it. So a list is a mutable data type. So what I mean by that is that you can just change the elements of the list and it will work out. It won't throw you an error. Unlike some other data types which are immutable, that is, you cannot change them. So as you can see, the list is now 1, 5, and 3. And a list is ordered in the sense that this indexes they go in ascending order, and we'll discuss more about it when we go to loops. So it can contain different data types. Even boolean and decimal values are allowed, float values. And then we'll get to some operations on the list. So the first one is how to add an element to a list. So to add an element to the end of it, you simply need to append. It is called an append operation. So we'll first, I'll just declare a list 1, comma 2, comma 3, and I'll do L. Am I audible, Bhavik?
Yes, you are.
Okay, okay, fine. I actually got a call. So if I append some value, let's say 420 to it, so let's see what the list will be. So so as you can see, the value is appended at the end of the list. On the other hand, we can also have another function. Uh, let's say I want to add two numbers into it in this order, particularly 420 and let's say 21. So how do I add two lists together? So it this time it won't be an append operation. It's called an extend operation. So it will change my list like this. Another way of doing the same thing is you can do L plus equals to. That is called adding a list. So you add the same things, 5 and 6. So this will also work out. Similarly, we have slicing. So just as you slice a string, we also slice a list. So it is done as follows. So since the first element is 2, I'll just make a bigger list for demonstration purposes. So the first element is 2. The second, let's say I want the second element is 3. So let's say I want the first two elements. So I will do something like this. Sorry, 3. So the first index is supposed to be the starting value. The second index is supposed to be the ending value minus 1, the output that we get. And we can also add a third value to it, which is the skip. See how many entries we want to skip. So let's say I want 1 till 5, but I only want the like even indices. So I will get 2, 4, 6. So like this, I can control the step size of it. So let's say I want to reverse the order. So for doing that, I will just do -1. So let's say I want to reverse a list. So I need to traverse it from start to ending and in a reverse order. So see, 7, 6, 5, 4, 3, 2, 1. So that's how you reverse a list by simple slicing. So let's move on to other operators. So there are identity operators, and identity operators like whether it has the same like reference or not. So there are like two things. One is called equals to operator, and the equals to operator assigns the same value. So you need to understand there are two things. One is called a value, and the other is called the reference ID. So I just run this cell. So Z has been assigned the same value as X, as you can see, but there is something called an ID for Z. So ID is the memory location where the object is stored. As you will see that the IDs for these two are the same because they point to the same value, but the variables are very different. But the variables are uh, s- but like but the thing is that like the IDs are same because they reference the same value, but they have different variables. So the is operator will yield a true value, while the is not will like again it will yield a true value because we have applied not here. So yeah, it's essentially a way of storing it in memory. Yeah, I'll just go over it again. So yeah. So the fundamental idea is that these two are different variables, but in the memory, if you think about it, there's some variables which have like static allocation, and there are some variables which have dynamic allocation. So for now, the is operator, how does this work is if they have the same value, if they reference the same object, then it will give a true value. So a list is an object, so that will work. But if let's see what happens if I do it something like this. Hmm, see, this is true. Let's say if I were to change it, x equals to, if I just change some random values, it will give me false. So it is as simple as that. The concept of IDs is that it's the memory location where this object is stored, and if I change one element of this, then it will give me false. So it did not give me false. So the reason for that is because uh, okay, because this is, well, I'll just do this here. I just made a mistake here. So yeah, that's what. Yeah, so it's supposed to give me false. So that is how it is working. Then we have the membership operators. So membership operators, what they do is whether a certain element is in the list or not. So two is in the list, so it will give us true, right? So yeah. Now let's move on to string operations. So concatenating a string, it is done by the plus operator. Let's say you want to repeat the same element in the list over and over. So in a string over and over. So how you can do is simply multiply that by some number. This also works with lists. So if you do something like this, you will get this, because essentially a string is just like a list of characters, list of chars. So whatever operation that is there in a string, an equivalent operation will also be on a list. So yeah, that is one thing. And then strings also support indexing and slicing, but the problem with strings is that they are immutable. So like you can index them using this thing, but when you try to change a value in a string, when you try to change a value, it will throw me an error. No, let see, because the data type is supposed to be immutable. Then we have some methods. So what is a method and what is a function? We need to understand the difference between them. So for now, I will explain you a method. So a method is a type of, you can say, an operation that is specific to a certain data type. So these to the data type string, we have specific operations such as upper and lower. So these convert them to uppercase and lowercase respectively. Similarly, we have strip, which will just remove the trailing spaces, and I'll just print these for your reference. So let's print stripped. So this blank space over here and this like these two blank spaces over here, they should be removed, and they have been removed. Then we have the strip. Then we have the split result. What it will do is it will simply split this by hello and world. So what it does is it returns a list where these two strings have been splitted together into splitted into two lists. Then we have something called a join. So a join is it takes in two types of inputs. The first input is what do you want to join it by, and the other is a list. So what it will do is it will take apple, add this separator to it. It will then add banana, add this separator to it, and add cherry. So joined will be something like, oh, sorry, I just added an extra D. See, so apple with the separator, banana with a separator, and cherry. Then there's a format option. So this is especially helpful when there is when we have to print something. So we have two types of format options. The first one called dot format method. So what you like, is it clear to now before I explain formatting? Okay. So the format option has two types. Basically, we have two types of format options. The first one being by the method, format method, and the other by something called fstring. So what is both of them? What are both of them? I'll be explaining. So you just look at these curly braces over here. So these curly braces will be referring to this variables inside it. So Alice is a string variable and age is well, it's a number. So whatever the data type is, they will be casted into the string data type, and the format method will just take them like this. So the first one over here will simply take it like this, and this one will be age. And then the other thing is fstring. So fstring allows you to put variable names there, so it is much more flexible. So just all you need to do is put an F outside of the string and then your double quotes or single quotes, and it will just do it. So yeah, that is pretty simple. Then we have if and else statements. So you must have done if else in like C. So the syntax is more or less very simple. For if, then we do not need any like any brackets or something. We can just go straight away with an operator. And if, then in Python we have something called indentation. So instead of having this curly braces, we use indentation. So this is what is supposed to be executed after if. Then instead of else if, we call it elif here, and then this part will be executed for elif, and this is called a block. A block is essentially what is inside an if statement, or what is inside an elif statement, or what is inside an else statement. So we have three options for blocks. So since x is 10, so obviously this will be executed. Then we have nested if. So inside an if, there will be another if. And as you can see that this block will be executed if x is greater than 5, this entire highlighted region of it. So yeah, and after this has been executed, we'll just check for the value of y. So since y is 20, so it's greater than 15, so the corresponding block for that will be this. So, yep. So x is greater than 5, but y is less than 15. Then we have the ternary operator, which is like a compact way of writing if else. So let's say the value I want to output is greater than 5 if x is greater than 5. So the block corresponding to if will come forward. So this is like a one liner for this thing. So a one liner is like basically the way of writing this entire if else statement into one line. So sometimes it is possible, but for a standard if else you don't want to like you want to make it compact. So that is why you use a ternary operator. So the else statement will execute like this, and yeah, that is as simple as that. So we generally use it well to make our code compact, nothing more. It's just it has the same functionality. Then is how you like take inputs in Python. So the inputs are taken using an input function. So this will trigger a like this thing prompt. So I can add as many characters as I want here, and this prompt will just is the message that you want to give to the user. So it will just simply print it. So let's say I want to add some new lines to it. So yeah, this as simple as that. Then let's say you want to take an integer value. So what you need to do is uh, just simply use the integer casting operation to take an integer value, and it will return you that. And if you let's say give it some random garbage, it will just throw you an error. So yeah, that is well how you do it. So that's all from my side today. Um, so yeah, Bhavik, I'm done for today.
Okay. So in the group, WhatsApp group, I have shared one link, a drive link. So what you need to do is download that. So the thing is, like what I will be doing, is I will tell you. In the previous session, we talked about object detection. You know, I think like most of you have been found it overwhelming. And what I have created is I have created a web application on which you just need to give the image and it will perform all detection part and show you the output. Okay. So first I will run it. Okay. Yeah. So the folder I have shared, there are certain images which are already present. Okay. So let's say I'm taking a single image. So I am putting this in this. So this was the original image, and after processing, you get the detection part. Okay. So you can see how simple we have made it for you to try out different, to try this out with different images. Okay. So another image. So you can see this is person. Then, so these are the images which we have. Another exercise, what you can do is, uh, you can go on this Google, search for example, bird images. Okay, take any image. Okay, so let's say we are taking this one. What I will do is I will save it. Okay, let's save it on desktop. Okay, on desktop I have done. So this was untitled. Okay, so I am doing this image. So what you can do, it is working for like the images which we are taking from the internet also. Okay, so ये चल रहा है. Okay, but how can you run it in your machine? Let's come to that part. Okay, so the zip which I have shared, usko you will extract, then you will get these kind of file format. So what you need to do is in that, if you have some environment ready, तो उस environment में कर लेना. If you don't know what is environment, what an environment is, leave it. So first, like I am activating my environment. Okay, इसको भूल जाओ अगर तुम्हें environment बिल्कुल नहीं पता, leave it. uh, One thing you need to make sure is you should have Python installed. Okay, after making it sure, just do like make this commands minus r requirements dot txt. So it will install all these the modules which are required for running it. So then press enter. I have already installed, so I won't be needing it. Then for running the application, you would need to write streamlit run this home.py, this file. Okay, you will run it. It will open directly on this. Okay, and then you can just directly कोई भी इमेज डाल दो इस पे. अच्छा ये वाले नहीं. Let's change the image. Okay, bird word. Okay, as a similarly you can do this. Okay, so what I need to do, you to do is try out with these images. Also, try out with different kinds of images. So you will find there are some things where this model is not working. Okay, I am giving you a hint. So try to save those images, and in the next session, I will share you another same kind of model, and we will perform the same task on it. And then uske basis pe I have some like very exciting exercise planned for you all. For those who know Git, like I have this repo also. Uh, I will share the link. ये same चीज है. Like from अगर you have experience with Git, you can directly do it. Okay. अगर नहीं है, so use that drive link and run these two commands after that. Okay, you will be able to run it most probably. नहीं होता है, contact me, message कर देना. Okay, I will share this GitHub repo also with you, and that's all. So try to explore and मजे लो इसके. Like we have made it for you guys only. Okay, then I think like we are done for today. So
Uh,
let's end.